Hey, it's Leah from Elia's Electronics, and I want to give a little introduction to interrupts on PIC microcontrollers. Now, interrupts can be generated by a couple of hardware modules, the simplest being the pin change interrupt. So it generates an interrupt when a pin changes state from either high to low or low to high. Then there are timer overflow interrupts. Several interrupts can be generated by the UART, the serial port. The ADC can fire an interrupt whenever it finishes a conversion. And the MSSP, which is the combined I2C and SPI interface, and the CCP, the compare module. So either if it overflows or if it resets the timer after a certain period of time. Now, what does an interrupt do? An interrupt interrupts the main program, and then it jumps to a certain place in memory. And that will look something like this. So you've got your main program running, instruction by instruction. And then let's say here is where the interrupt fires. Now, the microcontroller will execute the next instruction, and then it will jump to the interrupt vector. And the interrupt vector on PIC microcontrollers, on the PIC 16Fs, that's at address 4 hex, and on the PIC 18Fs, it's either the low interrupt vector is at 8 hex, the low priority one, and the high priority interrupt vector is at 18 hex. PIC 18Fs have a little different interrupt vectors because they have the ability to have low or high interrupt vectors. You can assign priorities to interrupt. So a high priority interrupt will always be handled before the low priority interrupt if a high and a low priority interrupt fire at the same time, or a high priority interrupt fires while there's a low priority interrupt handled. So then when it jumped to the interrupt vector, it executes the instructions into one by one in the interrupt vector, and after that it will jump back to the main program and continue with program execution. Now, how do you set up interrupts? Generally, you will first set up your peripheral, say your timer that will generate an interrupt on overflow. Then you will configure the interrupt of the peripheral, so you will say enable the interrupt of this peripheral. So when you enable the peripheral interrupt, every time the peripheral sets its interrupt bit, it will actually jump to the interrupt vector. Then you will have to enable the peripheral interrupts, so you can actually so that the peripheral interrupts will actually generate an interrupt. And finally, you will have to enable the interrupt itself. So that's a bit, it's called GIE in the intcon register. If that bit isn't set, then no interrupt will fire independently of if an interrupt is enabled of a peripheral. So if the ADC interrupt is enabled, but the general interrupts or interrupts aren't enabled in general, then it will not jump to the interrupt vector. And a rule of thumb for interrupts is that you will want to keep your interrupt service routine, so the code that's inside your interrupt vector, as short as possible, because you don't want to block any other interrupts. Because what happens is once it jumps to the start of the interrupt vector, all interrupts will be disabled so that no interrupt fires when an interrupt is being serviced. And the interrupts are re-enabled once the interrupt service routine is finished. And that's why you want to keep the interrupt service routine as short as possible, so that you get so that you don't miss any interrupts when they occur. I will give an example of the interrupts in the timers tutorial. Please give this a thumbs up and subscribe to the channel.